You might need to do the, oh, there it goes.
There it goes.
And then press this button here. Alright, so Scott, I don't think many of you know Scott. I used to work with him at Pivotal, had the pleasure of working with him for a while. He was actually the PM on the first team that I was on at Pivotal. So he works for Mongo now. He's the product manager of the drivers for MongoDB. So he'll be presenting on the MongoDB Driver for Go tonight.
Hi. So let me see if I can get this presented up here properly. I guess I will go to.
I didn't realize there was a chair over
And well, I get this where it needs to be. Here we go. All right.
there. Oh yeah, that's from that we're gonna. Yeah, they have like a bunch of merch on their website.
All right. Sorry about that. Hi, I'm Scott, as Jason said. If you can remember that as Scott Lamadou. So I can't take credit for this. A coworker a long time ago actually put that up on my door, and it's stuck ever since. So I am a senior product manager for drivers at MongoDB. I actually work out of Denver. The headquarters for MongoDB is in New York City, in Manhattan. There is another engineer who works in Boulder. There's no office here, but she works out of her house in Boulder. She's a VP of the cloud engineering team. That's right. MongoDB does have a cloud offering for the database, so it's called Atlas. It's a fully managed database. So she runs that team. And there's one other person in Colorado Springs, but otherwise that's the presence in Colorado. So go to the Gotham Go in New York City, and you can meet a bunch of MongoDB people there as well. So this is how you can get a hold of me or find out about me or ask me questions or whatever. I don't tweet a ton, so there's not much there, but feel free to find me there if that's your preferred medium. So I appreciate being here tonight. First of all, like Jason was mentioning, we've worked together and been buddies for a while, and I had mentioned that we were doing this driver, and he said, "Oh, would you be interested?" And I was thrilled to be able to come and just talk about this stuff tonight. So you'll notice in a minute, I'm really here to talk to you about this driver and Go, and MongoDB is a part of that. So there's going to be a little MongoDB slideware here, but I'm going to try to get through that stuff as much as I can to just talk about Go and the Go driver. This is, just so you know, this is sort of like an agile process here. So this is the beta release of this presentation. The first alpha went like this, so my dog really just didn't go for it. Kira, this is for you. I know how much you like puppy slides. So, and then my second audience, it went a little bit better. This is my bird, Sonny. He liked it a little bit more. He didn't fall asleep at least. So I'm hoping tonight you're a little more enthused, sort of like Sonny is at least. Get your head bobbing a little bit. So first of all, just a show of hands, who's aware of MongoDB and who's not? Who's aware? Okay, so everybody's aware of MongoDB. Who's used MongoDB? Okay, in a production capacity or just you've got to touch it and feel it a little bit? Looks like maybe a production one. Okay. So I'm gonna again some slideware sort of, and I hope it's not too kitschy, but some slideware about MongoDB, and then talk about what the database technology is, and that isn't just to market to you; it's to set up the rest of the talk about how this driver works. You kind of need to know about the database a little bit. So I'm going to go through some slideware here in terms of what MongoDB is. It's an intelligent operational data platform, so it's not just a data store. There's more to it, but the biggest thing is it's the best way of making your data simple to you to organize, use, and enrich in real time and anywhere. So you'll see that a couple more times here. So let me say, here's another view of that. So I think there's a couple of slides here that different folks use to express this in a different way. But the biggest thing I really want you to take away with tonight is the best way to work with your data, and that's what I deal with, is the drivers and how you interact with the data from MongoDB. So obviously, again, intelligent data platform, run anywhere. Here it is in French. So like I said, we've got a lot of slides that talk about this platform. Here's another one that talks about it in a little different way. Easy, way to work with your data. Flexible, working with your data, how you work with it. Again, these are things I want to come back to later when we're talking about the drivers. Great performance, again, something we'll come back to. And then versatile. So all these things apply to the drivers that I'll be talking about tonight. Another slide that talks about how simple it is. So now that we're done with that, let's get on to a little bit primer about MongoDB, the database, before we talk about how the driver works with it. So some terminology. How many of you have worked with just relational databases or tabular databases? How many have built an application that's gone into production off of one of those? Okay, so the numbers are overwhelming for that. So we can use this terminology chart here to talk about sort of the relationship between a relational database and MongoDB. You certainly have a database, and you might think of that as, some people say database, there's a cluster or an instance, that's a running thing, a server, and then inside of that, there are instances of a database. And so that's when I draw this diagram here, the database representing a single partition or useful grouping of your data into a database. You can give fine-grained privileges and those things. A table related to a collection, parent-child tables, so you may think of relationships in a relational database. You think of nested documents or arrays inside of documents in MongoDB. Indexes are very similar. Here's where things get a little bit different. MongoDB is based on the document model. So you think of a JSON document is really what you would think of there. And so when you get down to the actual data, we're not talking about rows and columns and tables, we're talking about collections with documents and fields. And that's what we're talking about when we talk about nested subdocuments and arrays. So a record or a row in a relational database is a row, it's a document in MongoDB. And that concept, the document, we'll talk about JSON and Beastson and those documents and how you manipulate data in a little bit. That's a key component of MongoDB, the database. Regardless of all the other things around MongoDB, like tools in the cloud offering and those things, it's based around the document model. Columns, so an individual discrete element of data being a field. We do have joins, so we introduced the $lookup. You'll hear $lookup. There's a lot of operators that come with the query language for MongoDB, and they're all prefixed with $, so it's $, whatever the operator is. There are views, and with 4.0 that came out 6 or so months ago, we do have multi-document ACID transactions now. So that's may help you orient from a relational model to the MongoDB model. And here you can see this is the document data model. So this probably looks familiar to you from a JSON document that you use. There are some special characteristics here, like ISO date. Those are actual extended JSON and Beastson data types. And so those are not just raw JSON data types. So next, Beastson. So Beastson is actually the underlying data format of MongoDB. So some people will sort of incorrectly say it's a JSON data store. It actually doesn't store JSON, it stores Beastson, which is the binary serialization of JSON. And actually this is a major component of the drivers. So we'll talk about that a little bit. You can read more about Beastson. This is not strictly related to MongoDB. You could use this for any other function you'd like to use it for. It's a spec for data format. So what about connecting to and using this thing here? Well, we've got a driver, and that's what we're here to talk about tonight, a driver. So we've got a driver for most of the popular and common languages. If we don't produce and support one ourselves at MongoDB, there's likely one in the community that either we foster or support, and we're looking all the time at languages that we might want to add to the collection that we produce and support. We also help support a bunch of frameworks that are popular in terms of integrating your data with MongoDB. So, and as you can see, we've recently betaed a Go driver for MongoDB. Yay! What are these drivers about? What are the aspects of a driver that are important for someone to know about a driver and have an expectation on those drivers? Well, first of all, the idea of providing this efficient and effective access to MongoDB in their native ecosystem. So that's a very important thing, that you don't have to try to learn some alternative programming model, frameworks to be able to use the database. Unified and unambiguous specs and implementation. So this is another thing that over the last couple of years the drivers have tried to do, and that's a lot about what I'd like to express tonight with the Go driver. And I think part of what, if you didn't read the description of the talk tonight, a lot of this is about how we built it and what it took to build it, and what that engineering experience was like. I'll have to be a proxy. I'm used to be an engineer, but today I only write sample code that you'll see later. So the idea being that to have a product, MongoDB, that someone who reads and writes Go can converse about with somebody who reads and writes, say, Python, we need to have the same common experience. And so to do that, we try to provide this unified and unambiguous specs and then implement those to the languages to the spec. So we also want to try to improve this developer experience when working with data-based applications. So that was really where MongoDB grew from, is that using relational databases as a developer can often be a challenge to convert from your mental model in your programming framework to converting to the data model in the database. I didn't include this slide, but it's actually a pretty impactful slide that shows an ERD. I don't know if anybody's ever worked in like a large enterprise or worked with a really large database schema. They can take up walls. The idea with MongoDB is you can shrink that data model down into something that looked much more like the JSON I showed before. It might be larger, but you can grasp the entirety of your data model for the domain you're working with by looking at that one thing, and it's all related there together, versus having to say, oh, there's a piece of data over here and a piece of data over there. Do they actually somehow relate together, and how would I join them together? So that's the sort of improved developer experience. And also really to provide an abstraction above the database so that you don't have to know about, it's a distributed database. So not having to know about all the nodes in your cluster, the driver can help take care of that. Not having to worry about failovers and retries and those kinds of conveniences help you to focus on the domain of the data you're dealing with. So that's what the driver's sort of purpose is. We decided that MongoDB deserved to have that delivered to the Go community. So why did we actually do that? Well, there was a Go driver already. It was commonly referred to as MGO. There were several forks of it. It was pretty well maintained. And so we had a proven ecosystem. We had proven demand. Lots of people were using this driver. Lots of people in the community using our community edition, lots of enterprises. But there is an article which you could read. I'll touch on some of the points here. That the effort in the community started to veer from one of the major principles of what we do with the drivers to provide this unified experience to these specifications. So when that community edition started to sort of diverge from the specifications that we have been writing for the set of drivers that are all implementing those specs, it became a little bit of a problem for our users as well as for us. We relied on that as well, which I mentioned at the bottom here, internal projects and products at stake. So we write our CI, which is called Evergreen on this tool. We have lots of enterprise tools, which our users use to do things like backup, whatever written in Go. Our automation and backup agents, major parts of our cloud automation and cloud infrastructure are written in this in Go and written against this driver. And so it became a risk to our business that that driver wasn't, not that it just wasn't under our control, that it wasn't really adhering to all the principles that all the drivers do, whether they're MongoDB contributed or community contributed. And so about a year ago, we let the community know that we were going to take on producing a MongoDB supported driver. It was not going to be a fork of the existing driver. There was too much divergence. There were some design decisions that were made that were difficult to sort of roll back. And so we let the community know. And to be honest with you, it was stated in this article, I think we all just have this in our spirit here, that the success of the Go driver and the fact that it made it where it had at the time that we started one is really owed to the community and Gustavo, who had been producing the Go driver for so long. So about a year ago, we embarked on creating a whole new driver for Go for MongoDB. So what are the aspects of building MongoDB Go driver? Well, first of all, as I mentioned, adhere to the specs. There are a lot of specs. I'll get to that in a second. And also, so meet those specs and also be usable in the language of the user. So idiomatic. So if you're using the Go driver and it feels like a Java driver, that's not going to be a great experience. If you're using the Go driver and it's looking like a single-threaded PHP driver, that's not a great experience. And so the idea being to write to the specs, but also produce it in a way that a Go developer feels very comfortable traversing from their application business logic code right over to the data layer code back and forth. So also, drivers are part of this distributed system. So I'll touch on some of the specs in a minute, but some of the specs define a large part of the distributed nature of MongoDB, like server discovery. So that's a big part of it as well. And then also maintaining performance while meeting the specs and whatnot. So a lot to hold there in terms of producing a driver that meets all those criteria, both meeting the spec so that you're producing the same product, making it performant, you could meet the spec but nobody could use it. So those are some challenges that the team had faced over the year. As I mentioned, spec heavy. So I actually had to condense this. I don't think you can read any of those. I've got a link over here to the specs. They're all available for you to go read. Actually, that's a great way to understand the behavior of MongoDB is to look at the specs. They're written in plain English, must, should, maybe later. It's up to you. So those are the language of the specs in terms of what an implementer must do. You can also watch this video that Chris Brando, it was recorded with Chris Brando at GopherCon this last year, where he goes through in great detail the pains that he had gone through in terms of understanding the spec and then trying to implement the spec and then rereading the spec and realizing, wait, that's not what I was supposed to do. And so he puts it in a really fun context in terms of baking and using a recipe and what that feels like. So I encourage you, if you want to understand some of the ins and outs of that, to watch that video and to read those specs. But if you can see here on the board, we have sort of 3 sets of specs that the Go driver would have to implement to be considered a fully compliant driver. The core driver features, I'll just list off a few here. Like this is Beastson. So I mentioned Beastson being the core of the data format of MongoDB. So in the server, that's how the data is stored in Beastson. Authentication, SSL. A huge one here, server discovery and monitoring. That means if you're connecting to a replica set cluster, which may be 3 or so nodes, maybe plenty more, the driver actually discovers and knows about those and then will monitor them to understand what their health is. And then if an election happens and a primary moves to a different node, it will know now I send my writes and reads over there. Or if a query is sent over with a read on a secondary is acceptable, it will know, okay, what's the best secondary I have with RTT so I can send it over there. So that's all managed by the driver. So that's why I say like the distributed nature of the system is actually also encapsulated in the driver. And it's important that each of those drivers function identically so that all users get the same experience from MongoDB. Server selection, so that's when you go to do an operation and you look at that RTT and server discovery and monitoring has been happening. Which one do I choose? So that happens on every operation. So you can imagine there, like, performance is a big deal. So we have read and write concern. So has it been committed on more than one node if I ask, right? So if I want to only read data that's majority committed, I can tell the servers that, and they'll only give me data that's been majority committed. So a bunch of these specs in the core, you can see actually transactions down here, And then we get into the API layer. So this is about the face of the driver to the user. Again, very important set of specs. Connection strings, CRUD operations, so everybody gets the same kinds of insert and update, delete operations, so that you're not talking like, oh, I did an update, and the other person is using a different language and a different driver. Index management, find, get more, and cursor operations. So imagine getting a record is different than getting a set of records, so you have to be able to stream over those. So those are some of the API specs. And then further down the list here, we have some sort of extended and advanced features. One interesting one is GridFS, so you can actually store files in MongoDB by just giving the driver a file, a stream of data, and it will then chunk that out and store it in the database in chunks for you. It's just storing it as regular data like any other data you would store, but it knows about it by a file handle. You can actually page through there and stream it to you and whatnot. So an interesting spec. A little bit newer one, command monitoring. And we have some new specs that will be coming out soon that have to do with connection pooling, connection monitoring, etc. So these are the set of specs. Like I said, spec heavy. So it's quite an ordeal to produce a driver that meets these specs. And again, I'd encourage you to watch Chris's video. It goes into much more detail in terms of, like in a Go context, some of the pains that he went through in terms of interpreting those specs into Go idiomatically. Meeting the spec. So that's great, but it also has to be usable in your language, as I mentioned. So an example of this is options. So when you, Go and optionals is a little bit of a problem. And so that's a real big design problem when the spec says you have to have these options that may or may not be included. So you could just choose a pattern, but to make it idiomatic, usable in language, friendly to a user, understandable, takes quite a bit of concern in terms of the options. And so there's an entire options package that deals with things like how you connect to the database, like how long am I willing to wait for my connections, how big should my pools be, when I do operations, what are my timeouts, what are my read concerns. So you can actually set these options from the database to the collection to the actual operation you do. So if you want to have it applied across the entire set of operations you do on this database, you can apply it at the database layer. If you wanted to apply that at the collection, just a single collection of data with similar documents in it, you can apply it and override the document level. And then again, every operation you do, you can set options on the operations as well. So some of the options, like we mentioned, a little bit difficult to deal with in the Go context of some of the options default to true, some default to 1, meaning true, some don't have a default. So there's these difficulties in modeling that and doing it in a user-friendly way. So that is, of course, the challenge with meeting a spec and constraints. I saw a really excellent, I was kind of struck by it, was a couple days ago, and not in context of this presentation, but on Twitter someone had said, I found a whole new respect for API developers, and now when I look at an API, I don't question what the hell were they thinking. I have compassion for them and question what must the constraints have been when they were developing this API. And so that's really what this kind of talks to. So again, part of the distributed system. These drivers function as a part of the whole. So DNS seed list and service records. So you can actually provide the driver with a service record which says, here's all the stuff about my database. It's a single URL, but it will then DNS look up the set of nodes in the cluster. So this record would actually have all the records in it. It would have all the options for which authentication database and timeouts and those things of that nature. So the driver plays a part in looking up that record and then discovering which members of the cluster to connect to. I mentioned server discovery and monitoring. So monitoring that cluster for status, health, availability, RTT. Status, I'm talking about elections. So it's a really crucial part that the driver does this effectively, because if there is an election, which they happen quite often, you may actually want to do that so you can do an upgrade. And so you can upgrade the secondary And then, so you can take the primary and move it over and then upgrade the next secondary. And so those things happen quite often, especially in like a managed environment. And so the driver has to be effective and efficient, both effective at discovering that an election has occurred and efficient in not taking too much time away from the actual application that it's servicing in doing that. Server selection, so every single operation, the driver is checking. It may cache some, but it's checking which one of these servers is appropriate for the command I'm issuing. So if it's a read command with secondary preferred, it would actually select a different node than an operation that was primary preferred. So the driver has to be very efficient in doing that, executing that spec on every single operation. And in transactions, obviously the overhead of managing a transaction and sharded transactions will be released in the summer sometime. We'll have a beta, I believe, in a couple months. The drivers actually play a huge part in this as well, especially in sharded transactions. So right now we'll have to pin to a specific node of the server to execute that transaction. So the drivers have to know, okay, I'm in a transaction mode and the transaction's executing, and which server should I be communicating with based on the last operation that occurred, and execute that operation. So again, that overhead during that operation has to be as small as possible. And as I mentioned, performant all along the way. So you imagine converting from that JSON representation that I mentioned earlier, that's totally acceptable to give to the driver to say, save this for me. And it has to interpret those strings that you give it into this binary data to save into the database. All your data. Server selection, again, I mentioned each operation goes through this process, has to be performant. Transaction, same thing. Overhead on each operation to understand that you're in a session and in a transaction, what the state is, which server to talk to before executing the operation. So with all that in mind, what did we do with the Go driver? How far did we get? How far have we gotten? Where are we headed? Well, as I mentioned, we published that blog post back in January, started the work pretty quickly. The first alpha release was in February. I did go ahead and cut out a bunch of those because we actually made it to alpha 18, which seems like a ton, but we were doing rapid iteration on these because of all of the desire to provide a great user interface and the difficulty of meeting the spec. So we just keep putting out these attempts at the best API possible and adjusting as we went. We did in December release a beta 1. That's API stable, so we believe at this point, unless there's some major problem that's discovered, the API we have is the one that people have been asking for. Beta 2 came out, added a little more backwards compatible support for server versions, so we went to 3.2, 2.6 and 3.2. And then if I move forward, we are fast approaching a GA. So we haven't had any major feedback that makes us believe we're not ready for a GA. We have some work to do, obviously, to get there. So there's some items to clean up, some documentation to do, making some things public, making some things private. But a lot of it is cleanup. So we'll have another beta out in just a few weeks, and then a release candidate fast followed by a GA. So that should cover us for the driver through 4.0. And then we'll do another release when 4.2 of the server comes out to support those features as well. So we are looking for people to try it out, see what they think. If you've never used MongoDB, it's a pretty easy interface. I'll show you some of the code in a moment. If you've done database programming against the database before, it's not altogether different. The Beastson data structures, the JSON data structures, some of the query language is a little different, but for the most part, it won't feel too unfamiliar to you. Let's talk about the MongoDB Go driver in action. Simple as go get from the repo. We are changing the repo, so if you come back to this recording or presentation deck later, we'll be changing the path to the repo actually to a MongoDB org path. So just be aware of that in the future, sorry. So it's easy as go get for the whole of the packages, or you can dep ensure to get each of the packages in this kind of command. I assume that's pretty familiar to most of you folks. Okay, so you import the packages. Again, I assume this is pretty familiar. So that'll get you started. Most of this code is sort of streamlinable here. It would function together, but I'm kind of chopping out some sort of ancillary pieces. So this is connecting to the database. I mentioned the connection URL, server discovery and monitoring, connection strings, etc. So that top line alone is the connect to the database. So you provided a context and you provided a URL to the location you'd like to connect to. You can easily run MongoDB local. It's pretty simple to download the community edition and start it up. If you're interested in playing around, I would actually encourage you to try Atlas. You log in, there's a free tier, you don't have to pay a thing, and you can spin up a small cluster that operates just like either a local one or even a larger one. And then it provides you a sample URL to provide to the driver. And then you can destroy it when you don't need it anymore and whatnot. And you'll get the latest version. That's it. I will mention that this is sort of a lazy connect. So that's the ping you see here, is actually attempting the connection and talking to the database. So you'll see there now, hey, look, we're connected to the database. And so at this point, the driver is actually doing a lot of those things. Server discovery and monitoring. It is actually reaching out to all the known nodes of the cluster. And so in this case, you could actually be talking to this cluster, and as long as it's a primary, the first time you connect to it, it will start telling you about it has a command called isMaster, so that the driver will issue. And that isMaster responds with sort of topology of the rest of the database. And so now in the background, the driver is trying to make sure that every next command you issue is appropriately distributed to the right node on the database. So this is just a sample struct that I'll use sort of it's not really necessary for the example, but just so you know, that's what I'm talking about. It's not something magical for MongoDB. So you have a data type in Go. So what do we do to actually get a handle to a database, or I mentioned a collection like a table, and actually do some CRUD operations? We just say client, which is the thing we created before, give me a database. So there's a database test. In MongoDB, it's pretty interesting. If you've used a database before and you try to insert some data into a table and the table doesn't exist, you get an error immediately. In MongoDB, it will just make a collection for you. It'll make the database and the collection for you, unless you don't have privileges, which in a production environment that may be the case. But when you're developing, generally speaking, it will just create this database for you. So if you download the binary of MongoDB, spin up the database, connect to localhost, never touch or admin the database, and issue that command, you actually do have a reference to a real thing in the database, which is a database called test and a collection called trainers, which you can put and get data from. So again, disconnect, pretty simple commands. Hopefully, again, part of the principles of the driver is to make this as easy as possible, feel comfortable. Hopefully these things look and feel pretty simple and comfortable in terms of Go program idioms. In this case, I'm just going to do an example of creating some data. This is some sample data. Ash, Misty, and Brock, these are trainers. They live in these awesome towns. Now I can insert Ash into the database and get the result of that insert. So as you can see here, I have an insert results object that's returned, and I'm actually able to get the ID of the inserted object and print that out. There's some other information in there. Obviously errors have information in them as well. So you get a response from the database saying, I have inserted this record for you. And if you want to look it up, here's the ID for it. All right, so now a little further into the world of MongoDB, Beastson, and operations. So generally speaking, a CRUD operation isn't just a find operation, or an update insert operation is not just here's my data, stick it in the database. You may want to perform some more complex operations. So MongoDB provides a rich query language called MQL, and that is represented in these operators you see, like $increment, that's $increment. There's a whole list of them. I have a link to the docs later. They're a little overwhelming at first because you may not have seen them in terms of like a SQL language. A lot of those are functions that are like mathematical operators or things like that. And MongoDB provides things like $map or $lookup or those things which are actually operators that you give to the database asking it to do the operation for you. So you put those into a document. So your query to the database is not only, or your results from the database are not only documents, your query is shaped like a document as well. So to construct a query, you can give it a filter, like I want to only do this for someone named Ash, and I want to update them. So you start with a document as a encapsulating object, and then you say, what is my operation? I want to increment this thing, and what is it I want to increment? I want to increment the age by 1. So that's what the filter is, and that's what the update expression is. So then you simply pass in the filter and the update to the update1 operation. And so the driver will take this and marshal it out to a command. To be honest with you, most of the work of the drivers is in interpreting Beastson and constructing a command. So all of the work of the filter, all the work of the index lookup, all those things are done on the servers, whichever node the member you end up hitting. But it is a pretty complex operation to take this Beastson object, take the operation that you've asked to have out of update1, and construct a command to send to the database. That's a pretty typical thing for a database driver, so not really exciting about it, but it is a thing to do. So you can, again, this is all open source code that you can go look at. I have a link to the GitHub repo at the end. And so you can see, like, what does an update1 actually do? Like, what does it go through to perform that operation? There are also options you can pass to this. Anyway, we're doing a filter. We'll be basically incrementing Ash's age by 1. So finding a document. We simply do a find one. So we're finding one document in the database. We can pass a filter. The filter was the same filter from Ash. And we actually pass it a set of results to decode. So you can do your own decoding. So when the results come back, the driver actually just has this raw Beastson. And you can produce your own encoding and decoding operations such that you can intercept the Beastson and translate it into something different than the standard Beastson we translate to these objects. So you pass it this var result, and it will decode the Beastson into that object for you. I mentioned options and the difficulties. You can see here, so there's an options package, you have a find option, and that has all kinds of unique options on it, like set limit. So you can set the limit to only find 2. And we'll do that and place the results in an array called results. So we just do a find. Instead of a find 1, which will distinctly return 1 result, regardless, we'll do a find operation that will return many results in an array. We're not going to pass in an actual filter, and we're going to pass these options of limit it to 2. And here I'm going to talk about the actual results or parsing the results and using the results, which is, that's a cursor that gets returned, a cursor of those documents that you found. So you have an actual array, a cursor of discrete document objects. So you just iterate over the cursor with next and decode each element similarly to the find one had the decode. So the element that you're decoding there is very similar to the result that we decoded before. And it's encoded or decoded into the trainer LM. And then this was appending results into the results array. Deleting, again, really similar operations here. You can delete many, delete one. You can pass it a nil. So here, actually, we're going to delete all the documents. So you can pass no filter and delete all the documents. If I wanted to have just deleted Ash, I could have passed in that same Ash filter, and we would have just deleted the document that corresponded to Ash. Similarly, you can drop the collection. So as I mentioned, if you don't have a collection and you refer to it, it will automatically be created by the database, and the data will just start getting inserted for you. So to drop that collection, you can simply do collection.drop. There are operations that allow you to pre-create collections, pre-create databases. etc. Depending on your use case, you might use those, or you might use this sort of inlined approach. I guess with that, I actually have, I'm surprised, I'm not sure where that slide went. But so we actually have the beta, like I mentioned, coming out in about 2 weeks. The Google groups have lots of content on using the drivers. They also have lots of content on sort of the approach we're taking with the driver. So you can ask, like, why are you doing this? What's happening? So it's not just support in using the driver, but about developing the driver. So you can see into the workings of creating the driver. There is a tutorial, which most of this code is available on, that I would encourage you to check out and try. I believe it does talk about using an Atlas database there, so it wouldn't be too big of a trouble to just go through that tutorial and just use Atlas without having to download too much. You go get on your way. Again, read the specs. There are also docs, general usage docs. There's API docs, etc. But if you're interested in, okay, like how would someone go about doing this kind of an operation like server discovery and monitoring, and thinking about the aspects of concurrency and locking and go routines and those things, you can read the specs and then look at the code and understand, like, okay, now I understand how something like that would occur in a driver like this. So I mentioned earlier being fostered along the way until we decided that this Go community really did need some assistance in terms of a Go driver to make sure it stayed on the right path. There is a Go migration guide that talks about all the things you might have to do if you were using the MGO driver. So if anybody had code that existed in an application that had relied heavily on the MGO driver before, this talks about some of the pitfalls, some of the sort of find and replaces you can do, sort of those gotchas. And like I mentioned, the Google group is a great place to get more information. And with that, I appreciate your time. Any questions?
Actually, I had a question. You mentioned the importance of the specs and the driver being compliant with the specs. Is there some type of like automated test harness that you have for testing compliance?
There is. So this is actually, I tried to include it in the talk, but it would have, it's a pretty big topic. There's an engineering talk, which I believe is public. I can share, I'll share it if I can find it. But it talks about the specs actually, when you write a spec, and I can actually, why don't I bring one up here. Let me see if I can bring up those specs and demonstrate a little bit of, here we go. So let's take the Beastson spec is great because it's actually a separate body that sort of creates. It's Beastson org that does that. So you can see here all the specs come with these tests, and there's 2 types of tests. There's a JSON/YAML tests that are completely automatable and orchestratable, and you can test, like automate test your code against. And then there are prose tests, which are left sort of up to the developer to interpret and implement tests for. And there's a specification for the runner of those tests. And I do think Chris doesn't go into depth about it, but Chris talks about those as well and goes over some examples in his sort of extended talk about the pains of and joys of building the Go driver. But there are each of the, let me see which one of these is, yeah, so here's a specification. Going through all the different aspects of this specific specification. So this is a set of behaviors for the drivers, providing runtime information about server discovery and monitoring to any third-party library, as well as internal driver use and logging. So we talk about server addresses, topologies and servers, what are events, operation names, and so we get into the actual API here, examples of code. Again, this is the spec that is agnostic to language. And then sort of some expectations on operations that it would perform, not just the attributes of it. And then tests. So there's actually, let me see, yeah, so I believe there's let me go back one and go to tests, and I'll show you the test there. I'm not sure I think this, yeah, so there's a set of YAML tests, and they produce these results. They're expected to produce these results. So does that answer your question?
Did any of these automated tests, were they a reason for like the change from MGO to the official driver? Is that because they weren't complying with those specs, or?
Yeah, I mean, there were lots of things, and we're still, like, we have customers who we support who are using the MGO driver, and that was the driver for a long time, so we supported customers who use that driver. That use that driver that had behaviors that were not consistent with the specs at all. And so if you were to attempt to execute these spec tests against the MGO driver, they would fail. Lots of them. And so that was a bit of a pain point. And you can, again, I mean, I think the MGO driver was actually an excellent driver. It was really good. The issue is that it's very difficult to have to express a product's operation, which has much of the product's operation in these drivers, and not know for sure that you can rely on the expectation that that driver would do that thing. And so that was a large part of that movement.
I have two questions. So one, it sounds like the driver has to do lots of things, right? I mean, the spec looks pretty big.
Mm-hmm.
There's lots of logic that has to be maintained locally. What's the overhead of using this driver, in regards to CPU memory and storage?
When you ask that, I don't know how to necessarily exactly how to express it to you. Like, what is the overhead? Most of it depends on, if you don't do any operations, it's very limited. It doesn't use a large extent of your CPU and memory to do the base operations that it does. I would say negligible. I think the word negligible would probably work there. For if you use the driver, you create a connection and that's it. Mm-hmm. I think you would probably not necessarily notice its operation in your application. When you start doing operations, obviously the efficiency of the Beastson library is a huge issue, right? It's doing a lot of manipulation of data.
It's doing that client side.
It is doing that client side. I mean, it receives a binary data back, and it has to get that to your native representation and into your structs or strings if you ask for it in that way.
Right.
We did see, I don't have the numbers, there was a pretty drastic improvement over the previous implementation with this implementation. And that was a focus, to provide that kind of performance, and both performance in terms of speed and also at lower cost. But it does consume memory when you're doing these database operations. I mean, it's you've got to collect the data inside your application. So it isn't doing as I mentioned, it's not doing the database level operations like filtering, choosing index, searching indexes, matching. It's not doing those in the driver. So those operations are not exhausting your resources.
But it sounds like generally like the design of Mongo pushes more responsibility towards the client.
I guess when you say that, I mean, there are things, yes, there are things. It actually, we try to make it as minimal as possible. In a sharded cluster, which I didn't really get into that topic, but there's a sharded cluster, which means you can choose a shard key and then have nodes distributed, and your data would be distributed based on the shard key. And so we definitely chose to not put that behavior into the driver. So there's something called Mongo shard. So it sits between all the shards and the client. Originally, we had the architecture that was recommended that you would put the Mongo S, this shardware thing, right up next to each of your applications. So if you were running a bunch of microservices, each of your microservices might have, like each of your instances of your microservice might have a bunch of Mongo S's right next to them. Since I would say it's probably been 2 years now, the architectural reference is now have a topology of MongoS's that you manage that your applications are aware of, that are separate from your applications. And they do things like, where is this piece of data in the set of shards? Rebalancing shards. So if you say, oh gosh, that split was incorrect, I'm no longer getting the efficiency of the sharding, you can ask the MongoS to distribute the shard, and it will rebalance. There's also an auto rebalancer, so but lots of people turn that on in production. And so that's not in the driver's realm. And so we try to take a lot of that kind of stuff out of the driver. It's mostly about that the client can use the server. So it's like MQL, the query language on this, is not in the driver. We do not interpret the queries at all. We interpret them into a command and send the command. If you gave us a query that doesn't work, it's going to get to the server, and the server's going to tell us. So it tries to be as efficient as possible with that.
The second question I have is just more of interest, because I know that if I had to design a driver, I would probably spend way too much time obsessing over that. Method naming. I noticed that some of your functions are verbs and some of your functions are nouns.
So there are a couple of things I would mention in relation to that. The team, there are over a dozen drivers. There are over a dozen driver engineers. There are approximately 4 leads or like architect level folks who oversee all of the drivers, but they really function also as engineers. And so these specifications are written by that entire team of people. So one person is a lead, they've got an architectural assistant, and then they work with their team, then we write a POC, and sometimes the specs actually go a little too far in describing the specifics of the operations, the nouns and the verbs. And so it's not left to the implementer to do that. Sometimes it is left to the implementer, and they say, I wouldn't have chosen to do it the way the spec originally wrote some of these things, but these other ones I have control over, and I'll write those this way. It's more common to use that way in this language. And so you will see a variance. We actually have an effort, I mentioned some other specs, and you can go see all this work on our Jira and in our GitHub repos, that there are some specs coming out about common options, like basically so that everybody uses the same connection options, connection pooling specifications coming out, so that when you start talking about connection pooling and one driver does connection pools one way and one does it another way, and all the options are different for configuring your max staleness and queue size and queue wait times, all this, like that everybody does it the same, so you don't get that kind of disparity across functions and drivers and whatnot. So it has happened. So these specs haven't existed since the beginning of drivers. So these drivers existed, some of them existed in a community and they were contributed to us. And so they may have some things that, deprecation is really difficult, it's painful. And so to remove an API can be difficult for somebody who's relying on billions of dollars of business through a MongoDB instance, and they can't rewrite their app. And so moving the API in regards to those kinds of things is difficult. So some of these are throwbacks to times when there were no specs. So,
thanks.
Yeah.
I have another question.
Yeah.
So this is a Go Meetup. I'm interested to know if or how extensive the use of channels were in the driver.
They're used. When I say extensive, I think there's a couple of places that are mentioned about in terms of server discovery and monitoring channels. No, I couldn't go into depth about. I wouldn't want to incorrectly be more. But I mean,
are they like part of the official API or channels of return?
No. That I think they're.
Internal details.
Yeah, I think they're internal details only. Yeah. I think the intention was to keep the interface like a document-looking interface. If that makes sense, but yeah. Hard to describe that in some other languages and meet the spec, and so. Yeah.
So something like the Beastson spec, And you mentioned that it's not even a MongoDB specific.
Well, I mean, we
So
do contribute to it and help foster it, but it is actually just an open spec. That's not a MongoDB spec. Yeah.
Sure. So the package level that you guys then included in your MongoDB driver, is that really geared directly to your use case, or is that sort of something that could also then be consumed by other packages or other, not drivers, but other consumers of Beastson?
It is intended to be a standalone library, and so that you could use it with whatever you chose. And actually, I kind of wanted to mention about the length of developing this driver, because it was a year to write a driver. Like, what takes so long? Well, it's a lot to hold all of those principles at the same time. And so Beastson was one of those very specifically where try to be as performant as possible. It's the underpinnings of most of the driver's work. You operate on it every day, so the API has to be sound. So there was actually several different, the package actually contains three really types of Beastson. So there's a raw, more performant Beastson. There is a more easy usable Beastson. They all end up coming down to the same Beastson, but the API allows you to function in a sort of a more easy accessible way, and one in a more performant but a little bit difficult to use way. So, but yes, it was written sort of separate from, I mean, it adheres to this spec and is intended to be performant beyond the use of using it for MongoDB.
Is the implementation part of the MongoDB driver source tree, or is it separate?
It is so if we go back to, let me go back, actually. And we can just kind of investigate that real quick. So you can see the Beastson library is part of the source tree. It is produced as a separate package, so you could use it independently as a separate package. As I mentioned, there's several different interfaces. There's the primitives, which are the raw underpinnings of Beastson, and then there are separate APIs to allow you to work with it in a much more fluid way or a much more performant way. There's also a codec, which allows you to this decoding and encoding, and I think most of the drivers now, there's not a spec for it. There's potential that one would exist at some point, but this idea of encoding and decoding and having you be able to provide an encoder or decoder from the Beastson to the result. And so you can actually do that. Our Beastson codec that we do as a default one is just an implementation of that. And that would, again, work regardless of the MongoDB server.
Sure. I just saw in the other specs like SSL and service discovery. I mean, I'm sure there's plenty of third-party libraries that do service discovery, but you probably also had to roll your own depending on how MongoDB does it. Yeah,
so that's the thing. It isn't necessarily just hey, we need to do service discovery. It is a very specific type of service discovery. Again, like these ismaster commands come back from your initial ask of the database, and then you start to get a view of the topology, which is a form of service discovery. But then it has to respond in a very particular way to figure out the rest of the nodes and put them in this order of which one should I contact first. And
yeah, so that was very specific to MongoDB.
Yeah.
Whereas the Beastson.
This is not. It is not. I mean, it is very specific in terms of the fact that it is our underpinning of our data types and our data store, but it is a transferable thing. It doesn't have, it in and of itself doesn't have specific operations to MongoDB. Yeah.
Great.
So this has been under development for a year.
Yeah, this specific driver. So the MGO driver has been around. I actually don't know it's been a long time. It's been around for quite a while, many years. I would say like 13, 14, something like that. This MongoDB Go driver was in development. It was actually probably before this article was written. I think there were some starts and stops, but this version of the Go driver, this actual implementation code base, was around January, February last year.